Hello, ladies and gentlemen. We're going to continue our discussion about forces and our introduction to forces by talking about something called balanced and unbalanced forces for the next couple of days. And so we're going to be taking a look at, first of all, what are balanced and unbalanced forces. And then hopefully by the end of the next couple of days in this discussion, you will also be able to answer how do unbalanced forces cause a change in position or direction and speed of an object when acted upon by unbalanced forces. Okay. Um, so let's take a look and review first what we've already talked about when it comes to forces. So, a force we already know is either a push or a pull. It can cause an object to either stop moving, to move, to change direction, or really even to change shape, right? Forces push either can push downward toward the center of the earth, such as gravity. Forces can also push upward on an object. Uh, and those are often called, and we haven't really used these terms yet, but they're often called either normal or supporting forces. We can see these forces both at work here on this table. There are a lot of other forces as well, and forces may or may not cause an object to move because we know it could cause it to stop. Um, and forces don't always cause movement, but they certainly can cause movement. So, for example, if you take a look at this table, we've got a book sitting on this table here in the picture, right? And um, this the book is not currently moving. However, there are forces at work on this book. There are all kinds of forces at work on this book. Um, One example of a force uh, at work on this book is the action of, or a force in this picture is the action of the book actually pushing down on the table. Okay. Well, at the same time that that is happening, there is also the force of the table pushing up on the book. If the book pushed down on the table without the table pushing back, the book would fall. It would fall to the floor until it reached something that could stop, force that could stop its movement. Um, the if the table were pushing on the book without the book pushing back, then again, that book would then end up flying up into the air. So those are just two of the many, many forces that are at work in this picture here, or even just in relation to the table and the book. There are forces at work all around us, even when things are not moving. But we also know that forces can cause movement, and so um, another example of a force of forces at work would be a car accelerating, which means that it is either changing speed or changing direction or changing speed and direction. And this, of course, is a form of motion. And so forces can either cause things to stay still, or a force can cause things to actually move. So let's take a look at what we mean by balanced forces and unbalanced forces. So I mentioned a moment ago that forces are at work all around us. Um, there's never just one force at work on an object. There are always at least two, and usually many, many forces that are happening all around us. And so, balanced forces are when you have two forces that are equal in size and they're acting in the opposite direction on the same object. All right. Uh, when those forces are balanced, when those two forces that are uh, working in the opposite direction on an object are also equal in size or equal in strength, then that object is going to stay still, or if it is moving, it's going to keep moving in the exact same way. So it's going to keep moving at a constant speed and in the same direction. So whenever forces are balanced, whenever all of the forces that are working on an object are um, are equal in size or equal in strength, and they all have an opposite force to them. So one is working in one direction, one in another direction. Maybe you have a bunch of forces working, but all of them have kind of another one that is opposite to it. All of these forces are equal in strength, then that object is going to keep doing whatever it was doing. If it was still, it's going to stay still. If it was moving at a constant speed and in a straight line, it's going to keep doing that. It's not going to change direction. It's not going to change speed. It's not going to suddenly start moving if it wasn't moving. So some examples, if you've got a race car that is at rest, it's still, it's not moving, then that means that all of the forces balanced, or all of the forces acting on it are balanced. If you have a small child who is for some strange reason sitting in the middle of the road, don't know why that would happen, but if if you do, and that small child is not moving in any way, but is at rest, uh, then then all of the forces that are acting on that child are balanced. They are equal in size or strength, and they are opposite in direction. If you have a teacup sitting on a table and it is not moving, it is at rest, then all of the forces acting on that object are balanced. If you have a horse that is moving at a constant speed, so it is continually moving at, I don't know, 10 miles an hour, and it continues in a straight line, it doesn't change direction in any way, shape, or form, then all the forces at work on that horse uh, are balanced. They are equal in size or strength, and they are opposite in direction. And if you have a motorcycle that again is moving at a constant speed and in the same direction, a straight line, so it's not changing at all, then all of the forces at work on that motorcycle are balanced. But let's take a look then at what we mean by unbalanced forces. Well, unbalanced forces are two forces that are unequal in size, still opposite in direction. Okay, so it is two forces that are kind of working against each other in that they're opposite in direction, but this time they are not the same strength or not the same size. And when you have unbalanced forces that are working on an object, this always causes a change in motion in at least one of these areas. It can either cause a change in its position, it can cause a change in its direction, or it can cause a change in its speed. So when those two forces that are opposite in direction are no longer the same strength, then you're going to have a change in motion. So for instance, we've got an orange box here that has a 10 Newton force pulling on it to the right. You've got a 20 Newton force pulling on it to the left. Those are opposite directions, but they are not equal in strength. They are not equal in size. And so the orange box is going to move to the left because the stronger force is pulling to the left. All right, we have a couple of horses here, horse one and horse two. Horse two is stronger. It's able to apply a stronger force. They are hitched up such that they would be moving in opposite directions, and therefore horse two would end up pulling horse won because it would be able to exert a greater strength in an opposite direction. Um, Down at the bottom, you have some race cars that are going around a curve. Because they are changing direction, they're not continuing in a straight line. That means that the forces working on on those cars are unbalanced. Even if they continue at a constant speed, because they are changing direction, we know that not all of the forces are balanced. If we had a student uh, standing with his arms out and two other students yanking on those arms. Please don't try this. The student that is exerting the strongest force is going to determine the movement of that student that is in the middle. So here we have two people pulling in opposite directions. So we've got two forces that are going moving against each other, so to speak, or at work against each other because they're going in opposite directions. But if one student uses a force that is stronger, then that will determine the movement of the student in the middle. So we can calculate net force. And net force is simply a calculation of the overall forces that are acting on an object. Force is, of course, as we already know, is measured in newtons. And we've got two skaters here that are pushing against one another. One is pushing with 3 newtons of force in the opposite direction of the other one, who is pushing with 2 newtons of force. So if we were to calculate that net force, because they are working in opposite directions, working against each other, we're going to subtract those two forces. If they were working together, if they were both pushing, say, on a box in the same direction, we would add their two forces together to determine the net force. But because they're working against each other, one kind of cancels out the other, so to speak, but not equally because they're not equal forces. And so we subtract, and so we have a net force of 1 Newton. And they, of course, will move to the right because the force that is pushing to the right is the greater force. So, how is it that unbalanced forces can cause a change in the position of an object? Because we said that unbalanced forces could change the position of an object, could change the speed of an object, could change the direction of an object. So let's start with the position. How can it change the position of an object? Well, if you have a skier that is at the top of a hill and they're just standing there, then the forces are balanced on that skier. However, if another skier comes along and bumps into him, there's an unbalanced force, a force that does not have another force acting. There are other forces acting in the opposite direction, but they are not equal in strength. That is going to cause the first skier to fall down, so their position has changed. This unbalanced force, excuse me, a little typo there, caused his position to change. So, how do unbalanced forces cause a change in direction, in the direction of an object? Well, again, we'll take a look at some skiers. So, a skier at the top of a hill, again, they're just there at rest. So that means all the forces are balanced. Well, then the skier decides to point the skis down the hill and push off. Now there are unbalanced forces at work on the skier. Again, lots and lots of various forces, but at least some of those forces do not have another force to kind of balance it out. There's not another force acting in the opposite direction that happens to also be equal in size or equal in strength. And so now you have a skier starting to go downhill. So the unbalanced force causes the skier to change her direction. How do unbalanced forces cause a change in the speed of an object? Well, if you have a skier that is at the top of the hill, all the forces are balanced. The skier, therefore, is at rest. Um, this could happen at the beginning of a race as the skier is flying down the mountain. Unbalanced forces are at work, and their speed increases or that he picks up speed. And so these unbalanced forces, these forces that don't have another force that is equal in size to it, that is working against it or in the opposite direction, um, when this force is stronger than the other forces working in the opposite direction, then that is going to cause the skier to speed up and gain speed as they head down the hill. All right, ladies and gentlemen, hopefully this has answered some of our questions about balance and unbalanced forces. Again, we'll continue to talk about this a bit in the next couple of days. I hope that you have a great day, ladies and gentlemen. Thank you.